Hello and welcome back. Today we are going to see a very interesting topic on Z-score. So what is this Z-score? Why do we need it? And what is the significance of this Z-score in statistics and in our projects of Six Sigma? My professors told me that you need this Z-score to get a numerical assessment of how far your data point that you want to investigate from the process mean. So you select a data point which is of your interest, and you want to know how far it is from my process mean. But then why do you need a Z-score for that? To identify the distance of any point from the mean, a simple distribution curve will tell you that. A normal distribution which you are using will tell you that. Any histogram will tell you that. Have a look at this. So I have in front of me a distribution curve, which I know my data is following, wherein this is the process mean. Now, if I want to find out the distance of this particular point from the process mean, all I have to do is to measure the distance between this mean and this point. That's it. Why do I need a Z-score for that? Story time. So there were two students, Peter and Shivam. Peter got 80% marks in English examination and Shivam got just 65% in mathematics. The school now wants to select out of these two a bright student or a brighter student for nominating in a competition outside the school. So whom should the school select? Peter with 80% or Shivam with 65%? Well, the principal said, my choice is very clear. It's Peter, of course. Can't you see he got higher marks? Don't you know 80% is higher than 65%? So the principal already gave his decision that his choice is going to be Peter because his marks are higher. But the headmaster had a problem. He said, "Sir, you can't compare apple and oranges." The principal said, "I am not comparing apple and oranges. I see that both are the same. After all, both of them are evaluated on a scale of 100 because the marks are out of 100 in terms of percentage. Moreover, they are taught by teachers who are selected by the same selection criteria by the school committee, and they are taught in the same environment. So where is the apple and where is the orange? I see that both of them are same." The principal also told that, "Don't tell me one is an easy subject and one is a difficult subject." The headmaster said, "Sir, it is not about easy subject or a difficult subject or both of them being taught by the same set of teachers who are selected by the common criteria or the same environment. The issue is both of them are coming from two different samples. That means both of them are coming from two different sets of data." The principal said, "How does that make a difference? If the two samples are coming from a different location, what is the difference? The school still remains the same, the environment still remains the same, the ranking system still remains the same. What is the difference?" So the headmaster said, "Sir, if the samples are coming from two different locations, that means the data sets are coming from two different locations, they will have different means and different standard deviation." So the principal said, hold on. What is this standard deviation? What does this mean? I don't understand. But I do understand that now there are two things that you are coming up with, which are totally different in the two samples because they are picked up from two different locations. Am I right? The headmaster said, yes, you're absolutely right. The two samples have different means and different standard deviation. And for that matter, sir, any sample picked up anywhere in the world, not in this school, will have its own mean and its own standard deviation. You change the sample location, it will have a different mean, it will have a different standard deviation. So now the principal said, okay, tell me one thing. Can we have a standard platform wherein the change in the location of the sample data is independent of the change in means and the standard deviation? That means this problem gets sorted out no matter from where the sample is picked up from. Now this difference of means, different mean, different standard deviation, different mean, different standard deviation, this should not happen if I pick up the sample from anywhere in the world. Can you do a standardization, please? So the headmaster said, sir, there is one Mr. Z-score who can do that. If we are able to find out the Z-score of any set of samples, if you have, for example, 10 samples from different locations, and we have a Z-score of all of them, all the samples become oranges, or all the sample becomes apples. So when we saw the Peter sample case, we found mean 55 and standard deviation as 3.6. And this was his marks, 80% in English. So we used the Z-score formula. So x minus mu, 80 minus 55, divided by the standard deviation, which was 3.6. And we got the Z-score for the Peter case as 6.94. Coming to the Shivam case, when we saw its mean was 56, he got 65% marks as indicated by the arrow with standard deviation 1.2. Again, using the Z-score, taking the difference 65 minus 56 divided by 1.2 standard deviation. Now see here, we got the Z-score for Shivam case 7.5. So the summary is Z-score for Shivam 7.5 and Z-score for Peter 6.94. This means Shivam was actually 7.5 units higher than the reference. And what is that reference? That we have created, because we talk everything now in Z-score, and Peter is just 6.94 units higher than the reference. So Shivam is leading. That means what? That means in that particular case, contrary to the principal belief, the winner is Shivam. So when you are calculating the Z-score, you're actually dividing the difference of the data point and the mean by standard deviation. By doing so, you are actually unitizing the difference of the data point and the mean. That means you are calculating the difference between the data point and the mean per unit of standard deviation. Per unit of standard deviation. So that means each sample will now have the distance of data point from its mean per its own standard deviation. That means now the distance from the data point and mean is described in terms of standard deviation. Now, when you do this, all the samples, irrespective of their location and size, start resembling almost similar in terms of the Z-score, wherein then you can compare different samples with respect to Z-score.